Hello and welcome. My name's Sean. I've been involved with aviation for 35 years. Started flying in 1984. I've flown most things that fly that don't have more than one engine. Today's presentation is called Operate Aeronautical Radio. Before we get started, I'm going to ask everybody if you could please put your names on this roll here so that we know who's present. And in the case of any emergencies, if the building catches fire, we're going to exit through the front door out here and we'll congregate out in the street out there. If you need the toilets are at the back here to the left, and tea, coffee, water back here in the kitchen. Okay. Operate aeronautical radio. Before we go any further, how many people here actually have operated radios? 1, 2, 3, 4. Well, most of you have had some experience in radios. Aeronautical radios are a little bit different to your UHF radio. There's specific terms, phraseology that you must use on aeronautical radios. We'll touch on that later. Our objectives today, as you can see up on the board here, is to understand each function and component of a handheld VHF radio. I've left my radio hiding somewhere, hang on. One of these. One of these. Okay. We also are going to be able to understand how to operate a radio and the elements associated with those operating functions. We're going to understand frequency bands and their function, understand the radio transmitter and receiver functions, understand the characteristics of a VHF antenna, discuss radio failure operations and emergency procedures, understand fault finding issues and how to deal with them. So that's what we're hoping to learn today. Okay. Communication systems involve voice transmission and reception between aircraft and the ground. For obvious reasons, we can't use sound as a medium. We can't shout at other people while we're flying, it's too far away and there's lots of noise. So we need a specialized system which can play an efficient role in transmitting important data. In this case, our voice. You can also transmit other stuff over the radio. And simultaneously maintain a good quality transmission. It can be said that safe aircraft operation is dependent to a large extent on satisfactory performance of communication systems. Radios are employed to fulfill this role. Power source and batteries. Handheld radios generally have a battery attached. On the table here in front of us there's numerous radios. Feel free to have a look at them, pick them up, have a play with them. Okay. You also have on most handheld radios, in fact just about every one I've ever seen, is an external power source. So you can plug an external power source into them. Ooh. Radios make noises. Okay. On handheld radios, the power switch is generally the on-off switch, the volume knob. Some radios may have a separate power switch, but most radios, the power switch is the on-off knob, the volume control. For dash-mounted units, there may be a separate power switch that powers up radios and things. All sorts of flashing lights on that one, Rob? Radio master. Dash-mounted units may have a separate switch that powers all the radio equipment in the aircraft. Obviously, handheld radios don't have master switches. The master switch is the on-off switch, basically. Dash-mounted radios, there may be a separate switch that powers radio equipment installed in the aircraft, as I said. Fuses, circuit breakers. Some aircraft have fuses and circuit breaker banks on the dashboard. Obviously, we don't have that with a handheld radio. Okay? An important part of your pre-flight checks is to check the status of any fuses or circuit breakers in that system. You may have fuses and things attached if you're connected to external power on your handheld radio. So if you are using external power, again, make sure that that power source is live. Microphone. For handheld units, there's usually a small hole in the casing on the front somewhere with a condenser microphone. Or alternatively, a handheld speaker mic might be installed. There's usually a plug, there's always a plug, to plug in a separate handheld speaker mic. The little plastic cover fell off my radio. Handheld and dash-mounted radios may be integrated with helmets that have speakers and microphones installed in the helmet. Some of the latest helmets may be connected to the radio using Bluetooth technology. That's the way to go, get rid of all the wires. Headphones and speakers. Both handheld and dash-mounted units have provision to connect headphones. Handheld units also have integrated speakers, so there is a speaker in the radio, obviously. So you don't necessarily need headsets and things, but it will improve your sound quality. Transmitter. The transmitter is contained within the radio. It's enabled when you press the push-to-talk button. There is also a receiver in the radio. It is enabled when you release the push-to-talk button. In handheld units, the antenna is usually a rubberized stalk on top of the unit. As you can see, all your radios have a rubbery stalk antenna. It's the standard piece of equipment. Dash-mounted units tend to have an external antenna which is connected to the radio via a coaxial cable. Some handheld units have a provision for an external aerial also. In fact, pretty much any radio you can attach an external aerial. You just have the right connection for the aerial fitting. They're pretty standard fittings. At any point during this presentation, if you have questions, provided they're related to the topic, feel free to ask them, okay? On-off switch. When on, the radio is normally in standby mode, i.e. it will receive incoming signals. The power used on standby is minimal. Your radio will last a long time if it's just sitting on standby receiving. PTT, push-to-talk or talk switch, the radio cannot receive and transmit at the same time. So this switch must be held down whilst transmitting. Okay? And then released as soon as you've finished your message. So that the set returns to receive mode. Be careful to avoid holding down the push-to-talk switch. For example, by sticking the radio in your pocket. If the push-to-talk switch is pressed, the signal will be transmitting whether you're talking or not. And that can be rather embarrassing if you're holding a conversation with somebody. Everybody's listening. Microphone. Locate the mic and hold it close in front of your mouth. Not too close, just somewhere near your face. There's a microphone in the front of the radio. Will pick up your speaking. Be aware of wind noise if you're in an environment where there's wind, because you'll get wind noise over the microphone. Speak normally. Do not try to raise your voice when speaking into the microphone. Some radios might be supplied again with a separate mic that plugs into the radio. We've already talked about that. Squelch. On this particular radio, the squelch is a small collar that fits around the volume control. Lots of different radios have different methods of adjusting the squelch. Some it's in the settings, some there's a separate knob. There's all sorts of different settings. Know your radio. Learn how to operate it. Okay. To remove unwanted background noise, known as static or hash, switch on the squelch switch. If there is a squelch knob, turn it until the hash just disappears, until that static noise just disappears. Don't turn it too far or you may lose your incoming signal. If the signal is weak, you may need to turn that squelch button down so that you can hear that signal, in which case you will get that hash noise also. Note, if you leave a radio on standby with the squelch turned down, you will get that static noise and it will eat up your battery quickly. Frequency control. This may be a rotating switch. There is a rotating switch on this unit. There may be separate switches for each digit, or a keypad. We also have a keypad on this radio. Most modern radios have keypads. And it's usually a rotating switch as well. I've lost where I was now. Or a keypad. Some sets have the option for preset frequencies. Most modern sets have the option for preset frequencies. Frequency lock and scan functions. Make sure you know how to use these functions, especially how to lock and unlock, as you may have to change frequencies accurately and quickly when needed. Power source. You are required with a handheld unit to carry spare batteries or have an external power source. Know how to charge your batteries, change your batteries. If a low battery indicator shows, the signal becomes weak. The output of a radio is measured of the signal strength, usually expressed in watts. So this is a 5-watt radio. Most of these radios are 5-watt radios, which is quite powerful. You can transmit for a long way. Again, some radios are fitted with fuses. Check your fuses if you have them. Communication phrases. You'll find a handout. You will when I give you it. Okay? Here we have some handouts. If you can just take one and pass them round. There's 2 different, so one of each. These handouts contain all the communication phrases used. They're important phrases. Remember to keep this handout handy, because I'm going to ask you to spell some stuff in the phonetic alphabet. And I'm going to ask you to make a couple of calls properly. So letters are spoken using the phonetic alphabet, e.g. P-O-N is Papa, Oscar, November. Numbers are slightly altered to improve clarity. They need not be exaggerated, just spoken clearly as shown on the handout provided. You'll see there's a bit on numbers beneath the phonetic alphabet there. If radio reception is poor, a word can be spelled out letter by letter using the phonetic alphabet. Standard words and phrases. These are used to avoid misunderstanding and reduce communication time. Radios sometimes can be quite difficult to hear, so if you use standard phrases and standard terminology, everybody can understand you quicker and simpler. Okay. We'll have a little bit more of a look at those handouts in a little while. I'll get you to have a look and I'll get you to spell your names and things. Airband radios transmit and receive radio frequency. Radios are set to transmit and receive on a specific frequency across a band of frequencies. The radio waves that are transmitted and received are based on wavelengths and amplitudes. So as you can see on the diagram, the distance from peak to peak or trough to trough, any two corresponding points is your wavelength. Your amplitude is the height of the wave. Okay? The higher the amplitude, the higher the wave from peak to trough, the stronger the signal. A cycle is one complete wave action. So from peak to peak, as was shown on the previous diagram, that is one wave action. The frequency measured in hertz is the number of cycles, so the number of waves passing a given point in 1 second. A given point, if you like, is your area. 1 cycle per second is 1 hertz. 1,000 hertz is 1 kilohertz. 1,000 kilohertz is a megahertz. And 1,000 megahertz is a gigahertz. The wavelength, as I've just discussed, is 1 cycle. The height of the peak or trough from the center line is called the amplitude. The greater the amplitude, so again the greater that wave is, the higher that wave is, the stronger the signal strength. Signal strength reduces gradually with distance, or more quickly when signals pass through more solid barriers. This reduction is called attenuation. All happy, Dave?
Oh, good, yeah, no, I'm just checking something.
Sorry? No, that's fine, that's fine. Amplitude modulation, AM, is where the amplitude of the signal is varied while the frequency remains constant. So the same amount of waves are coming through, but the amplitude is either greater or smaller. Frequency modulation conveys information over the carrier wave by varying its instantaneous frequency. So the more you squash up those waves or separate those waves, that is actually carrying information. Transmitters may be considered as generators, which change electrical power into radio waves. It basically performs these functions. It generates an RF radio frequency signal, amplifies that RF signal, and provides a means of placing intelligence on that signal. In other words, in our case, voice. Basic functions of a transmitter. You have your frequency oscillator, frequency multiplier, an audio microphone, an audio processor, which then feed into a modulator, which then go to a power amplifier, and finally that signal comes out of your aerial. A radio or FM receiver is an electronic device that receives radio waves and converts the information carried by them into a usable form, in other words, our voice. An antenna is used to catch the desired frequency waves. The receiver uses electronic filters to separate the desired radio frequency signal from all other signals picked up by the antenna. An electronic amplifier increases the power of the signal for further processing and finally recovers the desired information through demodulation. Now we've got fireworks going off outside. I wonder what that's now. So here we have a diagram of a basic receiver. You have the aerial, this is an aerial here, which is into the RF amplifier, and a mixer with a local oscillator feeding into that. That is then fed to the IF amplifier, which then goes to the detector or demodulator, and then onto the IAF amplifier, and finally out the speaker where somebody's voice appears. All instantaneous, amazing. Antennas. Characteristics of a VHF antenna. In a VHF radio, an antenna is a metal rod tuned to a frequency by its length. So inside our little rubber aerial here, there's actually a coil of wire which is a specific length. So that is tuned to a frequency by its length and connected by a coaxial cable. Well, in our situation, it's a direct connection rather than a coaxial cable. The dash-mounted units will tend to have the coaxial cable connection. And that goes into the transmitter. If an antenna has the correct length and meets other properties, almost all the energy sent to the transmitter. Sorry about that, people. I should have turned my phone off. I should have asked you to turn your phones off too. Never mind. It's off now. Where was I?
Yeah, antenna as well.
Okay. So if the antenna is tuned properly, almost all the radiation, all the energy put into that antenna is radiated out of the antenna rod. If the antenna is not tuned correctly, correctly, then some or all of the power sent via the transmitter may be reflected back through the transmitter and not radiated into the atmosphere. This can damage your radio, so make sure you've got the correct. It's alright, you can put any old antenna on there, but it could damage your radio, so please make sure you've got the right aerials attached to your radio. Okay. In the next section, we'll focus on emergency procedures and fault finding issues. Questions?
You said the power of the radio is like 5 watts. Is that like, what, is that the minimum?
That's the output of the radio. The radio is transmitting out 5 watts of power. You can have a switch on there which will drop you onto low power. The higher the power output, the more power you're using from your battery. So sometimes you'll have a high power and a low power setting on your radio. If you're only transmitting locally, it's often a good idea to be on low power. Your radio will last longer. If you've got weak signals or you're transmitting longer ranges, it's a good idea to have the radio on high power. Any other questions? Can it give you cancer? I'm not a scientist. I don't know the ins and outs of it, but any radiation has the potential, as far as I understand it, to cause genetic defects. Your mobile phone is no different from a 5-watt radio. They're all radiation sources. All radiation sources, I believe, have got the potential to cause damage.
The only difference is this puts out 5 watts, this puts out a fraction of a watt.
Yes. Yes, your radio is vastly more powerful than your phone. However, your phone tends to be stuck next to your ear all the time, or in your pocket all of the time, whereas your radio is only close to your head whilst you transmit or you're struggling to hear a received call. I've been flying for 35 years. I'm still here. The radio hasn't killed me yet. I don't think there's too much danger involved with radios. We're surrounded by electromagnetic radiation everywhere we go in this modern age.
Sean, what are the, like, in these radios, where do you buy them from, and do you need to keep like a spare battery, or what do they cost?
Okay, your handheld VHF radio, you are required in aviation to carry a spare battery or to have an external power source. You can buy a VHF radio basically from any shop that sells radios, the electronics shops. I'm not going to give you any specific shops, I'm not about advertising, but anywhere that sells radios should be able to sell you an airband radio.
Special for $339 at the moment.
Oh, whereabouts?
Manila Guide.
Okay.
How much did you pay for that?
$339 at the moment.
That's a pretty good price. It's a pretty good price. When I bought this one several years ago, it was about $600.
They've come down here.
Will that radio that you've got do like your normal, like, will it only do air bands or other bands?
So this one's an airband radio. It's a VHF, and you can get marine VHF, which is a different band altogether.
Yep.
Requires a different license. The airband radios that we have a 5 watt.
Yep.
If you've got a marine band, you can get a 5 watt on handheld or a 25 watt in dash. So, and that there it's got on the top of the boats.
You can buy VHF airband radios that will do other frequencies like UHF and things, but they're pretty rare. You have to do a lot of hunting to find them, and they tend to be somewhat expensive. Most airband radios are purely airband, and remember, although anybody can buy an airband radio, you must have a rating to use it. Sorry people, I'm going to have to take this call. Kimmy, I'm in the middle of it. Hello?
Interestingly enough,
Hello baby, I'm in the middle of a presentation.
some of these are available on
Alright, I'll call you back.
eBay, and different brand radios for like $50 and $80.
Yeah.
And they say airband, but they have to have what's, the Australian, that little tick that you see next to Telstra phones.
Yeah.
It's got one of those, and it's legal. Otherwise, it's illegal. You get a $12,000 fine.
They don't like people using airband radios that aren't certified to use them. You know, they don't want Joe Schmo talking to the 747 pilots, because remember, with this radio, you can talk to air traffic control, you can talk to every aircraft in the sky. So they don't like people messing around with them. They tend to get upset.
The other thing too with those cheap ones is they call them dirty frequencies. So you might transmit on a frequency that's say 132.5 or something like that, and when it transmits on that, you may think you're not interfering with the frequencies on either side, but because it's a dirty signal, it actually interferes with those other signals. And people who are using the radios genuinely can have their communications interrupted. So it's really important that you do get one with a tip, so it doesn't interrupt those other frequencies.
Thanks for that, Dan.
Sorry.
That's excellent.
Sean, you wouldn't use this radio for just normal sort of towing,
No.
would
No.
you? Or,
No.
Yeah.
Use this radio as sparingly as you can.
Yeah.
For normal flying use, in your case with hang gliding, no, you'd use a UHF radio. This is purely if you're in a situation where you are required to carry and use a VHF radio. In a hang gliding field, above 8,500 feet, you're required to have an airband radio, and any time you're flying in a specific airspace that requires you to have an airband radio, like a CTAF-R. Anything else? We'll take a short break, and we'll do something else afterwards. Or maybe we'll hand out some information. What I can do is, for those who want to do their radio endorsement, I'll hand you out some workbooks and the textbook for you to have a study, and you can sit your airband radio endorsement, not tonight, but we'll do it another day. Okay? All good? Okay.
Thank you so much.